Good day, my natural science learners. I hope you are keeping fantastic and that you are keeping safe in these difficult times. Now, I hope you are ready today to learn something new. So let's get ready for today's lesson. I hope you enjoy. Grade 6's today's topic is using electrical circuits, and today is lesson 19 and the date is the 3rd of September. So before we get started with using electrical circuits, let's have a look at the instructions. I'd please like to ask you to remember to write your date and your heading. Make sure you write neatly and clearly, and of course use lots of color. Now, I know some of you have an academic pack, so you are more than welcome to cut and paste the PowerPoint presentation in your workbook, or you can keep it nicely in a flip folder where you remember where it is so that you can study. Now, if you are unable to print the notes yourself, just remember you can write them down by hand. So most importantly in today's lesson, I'd like to ask you to take some notes. Then once you're done, I'd like you to complete the activities required in the lesson and remember to rule off your work. I hope that you enjoy today's lesson. So grade 6's, we are going to discuss using electrical circuits, and what we need to remember is you've learned what an electrical circuit is, you know the different components that we need in an electrical circuit, and you have learned how to draw a circuit diagram. So now we are going to move into using electrical circuits, and we are going to discuss the system, input, process, and output. So when we think of a system, it is something that is made up of two or more parts that work together to do a specific job. So when we think of an electrical system or an electrical circuit, we need to break up the word and look at a system. So when we think of a system, it is something that is made up of two or more parts that work together to do a specific job. Then when we look at our input, it's a component that goes into a circuit and provides the energy to the circuit. So when we think what is our input of the circuit, it's the thing that provides us the energy. Now, an input is a component that goes into a circuit and provides the energy to the circuit. I want you to have a look at a circuit and think, what provides us with the energy? What is the source of energy? Now, if you thought of a battery, well done. Then we move to the process, and the process is the way in which the input is changed to the output. So the way that is changed from an input to an output, that is the process. So what process does it go through? And this is the link between the input and the output device. Then when we think of our output, we have to look at a component that causes the results in a circuit due to the input component's energy. So let's say our input is a battery. The process is the battery transferring the energy through the circuit and a light bulb. The output would be light energy. So the input, our electrical energy, the process going through the circuit, and the output would be providing us with light energy. Using electrical circuits are used to solve problems that require energy. Circuits are used for street lights, traffic lights, alarms, electric gates, fans, and heaters. So when we think of electrical circuits, we should think about everything around us. Electrical circuits need at least 3 components in order to work. Now remember, the 3 components that we need is our source of energy, our conducting wires, and of course the device. So when we think of this, we need to think of they need a source of electrical energy. So where does the energy come from? Then we need to look at our conducting wires and obviously the output device. So when we think of our source of electrical energy, we should think of our batteries, our cells, and our motors. Our conducting wires, of course, remember, they need a conductor and an insulator to protect us. And then our output device, we can think of our light bulb or a fan or a buzzer. But just remember what we need to understand, grade 6's. is that we also get a control device, which would be our switch. Now, the output device changes electrical energy into another useful energy. These output energies are light, movement, sound, and heat. So when we think of an output device, it needs to change electrical energy into another useful energy. So a light bulb changes electrical energy to light energy. So when we think of a light bulb, remember electrical energy becomes light energy. When we think of a motor, it changes electrical energy into movement energy. A buzzer changes electrical energy into sound energy, and a heater changes electrical energy into heat energy. I'd like you to take a moment and think of other devices that you know can change electrical energy into a different type of energy. And I'd like you to make a list of 3. Now, circuits are used to solve problems. And remember, there are circuits all around us. So some circuits produce movement. If we think of a fan, these are blades that turn very fast. Now, a fan changes electrical energy into movement energy. Some circuits produce light. If we think of a torch bulb, it changes electrical energy into light energy. Some circuits produce heat. I think we should take a moment and wonder what produces heat energy for us. Now, an electrical stove, a good example, changes electrical energy into heat energy. And a stove uses a heating element to do this. Some circuits produce sound. If we think of a doorbell, it changes electrical energy into sound energy. Now remember, it's important for us to remember what was the input, the process that it went through, and the output. And remember that energies can change from one to another. So when we take a look at using electrical circuits, let's have a look at some examples. When a cyclist rides a bicycle, the energy is transferred. The cyclist pushes the pedals. This would be the input energy. The energy is then transferred by the different mechanisms of the bicycle. It changes to movement energy. This would then be called the output energy. So we need to think of the cyclist who is riding his bicycle and how energy is transferred through the cyclist. When he starts pushing the pedals, this would be the input energy, him putting energy into the pedals, pushing them. And this is when the energy is transferred, which we use different mechanisms inside of the bicycle to actually move. Now remember, this would then change the input energy that is put in into our output energy, which would be movement, the bicycle going from one point to the next. Then we need to look at an electrical circuit, which is a system that is made up of different components. Each component does something different, but they all work together. If certain components were removed from the system, it would not work. The basic components of an electrical circuit include things like cells, light bulbs, conducting wires, buzzers, and switches. But now you have a bit of an example when you think of a guy riding a bicycle. This is how we use electrical circuits and how energy is transferred and how we get our input, process, and output. So when we look at electrical circuits that produce movement, we can look at a toy car which moves when the motor is switched on. The wheels of the toy car are connected to a simple electrical circuit. The circuit is connected to 2 cells, which provides power to the electrical motor. Now when we switch on the motor, this provides electricity and the wheels of the toy car move. Now, the different toy cars have moving parts that work with batteries and are moved by electrical motors. Other examples of objects that use electrical motors to move are electrical gates. The turning blades of a small handheld misting fan are also moved by a motor when the switch is turned on. So when we think of circuits that produce movement, we need to look at how this toy car moves. So number one, it takes the first step by using electrical energy and it changes it into movement energy. And when we think of the input, the process, and the output, we need to think of the input being the toy car, the motor, which is providing us with the electrical energy, the process, you switching it on, and the output is when the toy car moves from point A to point B. Now grade 6s, for the next slide, I'd please like you to pay attention and watch the YouTube video. And in this YouTube video, it's going to help you with activity 2 of making a circuit with an electrical motor. I hope that you enjoy this YouTube video. Pay attention, watch carefully, and remember, if you are able to do this at home on your own and you have all the equipment you need, you are more than welcome to. But remember, if you do not go out and buy it, as it is not necessary. You can just watch the YouTube video. I hope that you enjoy it. So grade sixes, I hope that you had a wonderful lesson, and most importantly that you actually have a good understanding of how we use electrical circuits in our day-to-day lives. I hope that you have a better understanding of how energy changes from one to another and how the input and process changes to an output. I hope that you understand how a system of energy works, and remember that when we have an input, a process, something changes to create the output. Now, please make sure that you have these notes in your workbook, and I'd please like to ask you to do activity 2, number 2, on page 138 of your natural science textbook. Now, if you have not got it, I have uploaded a scanned version onto Google Classroom, as well as I have put the activity 2 on the next slide of this video. I hope that you enjoyed today's lesson and that you learned something cool and interesting. Waiting for you to join me next time. Have a wonderful day further, grade sixes.